Hello and welcome. This is Mouse Gunner, and we're back with some more Automation, the car company tycoon game. Continuing on with the campaign roleplay of the Edison Car Company in 1996. And in this video, we're going to be working on the engines for the Edison Satellite, which is a more economical sports car. And this is more than likely going to be the last year for the Satellite, as I don't think it will continue on into our next year period of 2001. In any case, for this build, I'm going to be using pre-existing engines, and the two engines I'm going to be using is the LB 1.6 and the SB 2.0. So we've got a 2-liter inline 4 and a 1.6-liter inline 4. And we're going to start off with the 2-liter inline 4. Now, I never really know if these engines are going to fit into the models that I intend to put them in until I have done the build, and from what we've seen previously in the game, sometimes there's an issue with mounting transverse engines into models, even if it seems like they should fit. In any case, we're going to go ahead and revise this engine. We're going to make a clone of it, and we're going to try and push it for a more performance-oriented build. Right now, it's only getting 111 horsepower. I probably want to bring that up at least 20 horsepower, if not more. So it's going to be a tall task that we're going to be trying to attempt here. So let's make the clone. And where do we want to start off? Well, we could start here with the conrods and pistons and try and make this a higher revving engine by giving it better parts, giving it I-beam steel rather than cast parts would be a good way to try and push the performance of this engine. Some other things that we can do is we can change the catalytic converter from a 3-way to a high-flow 3-way, and we can see that immediately gives us a performance boost. I think I'm going to keep with a reverse flow muffler, though, rather than a straight through, as I don't anticipate that will really help our performance all that much. It might reduce weight overall, so what I would more than likely do, rather than just use one straight through, I'd probably use 2 to get that loudness down, because that's quite loud, 51.8. And if I were to do that, currently the weight is 256.9 with one reverse flow. If I do 2 straight flows, we can see that does increase weight. So, and it will probably increase cost as well. I'm not really seeing a benefit in performance, at least at this point. So I think I'm going to go with just a reverse flow muffler. Keep things simple. This is supposed to be a cheaper build than what we're going to have with the Comet in the future, so we don't want to get too crazy here. Okay, now that we've done that, another thing that we can do is we can mess with the fuel mixture, which would be a nice way to get a lot more performance out of this engine, make it a lot easier to do so, for sure. And honestly, that wouldn't cost us any money to do so either. So that would probably, you could argue, be one of the best choices to getting the more performance out of these engines. But let's start with better conrods and pistons and probably a better crank here as well. What is the difference between the cast iron crank and the billet steel? Or even forged steel, if we want to go a little bit cheaper. I think we're going to end up going forged steel. As we can see, the production unit time is a lot more generous for us. Now, billet steel has the advantage of being a lot lower weight. Now, if I remember correctly, this engine is aluminum block and head, so this is going to be a pretty lightweight engine anyway. Let's go ahead and go with the forged steel. That's going to make the engine run smoother as you have less reciprocating mass. And we're also going to go with I-beam steel and forged pistons. Now, you can make the argument that this isn't really realistic for the kind of build we're going for. And I would probably tend to agree with you in most instances. Probably be more realistic to keep the cast construction, keeping costs low. But I'm going to try this out, and we'll see where we're at as far as that goes. Usually my cars are cheaper builds anyway. They tend to be pretty affordable. So sometimes I feel like when we add more expensive parts, I can get away with it because I keep costs low overall. But in any case, one thing that this will allow us to do is really mess with the cam profile, which honestly is already set up pretty aggressively. But we could push it a little bit further, get it up to, let's say, 55. which is going to push that performance up. Now we're have increased it 9 horsepower, and we still have a lot of room to move. We have a decent amount of fuel octane to work with. We could ramp up the compression ratio. We could ramp up the ignition timing. We can also push out the RPM limit, as we did make the parts be able to handle that more. So let's find our peak performance here, which looks like it's at 6,800. We do have valve float though, so we do have to consider that when we're pushing this engine hard, that eventually the valve float's going to get out of hand and really hurt us. But we're able to easily get our peak performance index here without hurting our reliability very much at all. So that's good to see. And of course, we could go more aggressive with the cam profile, but at the moment, I don't want to do that. What I am going to do, as I discussed, is move the fuel mixture around here. I'm going to go up to 14.5. Now, one commenter did point out that this isn't really a very realistic fuel mixture setup, especially for this time period. And I agree with you, but I do this more as a purposeful way of limiting the engines, as without it, oftentimes it's very easy to build overperforming engines. So I try and limit myself in some way. And also for my previous experience in the game, now I must admit that it's been a little while since I've played, so my memory of this is, it's rusty. And also, there have been changes in the game, and I think one of the things they did rebalance was how fuel efficiency works. So we'll have to see how that works in this year period once we get into the actual car models to see if maybe I'm overdoing this, going for more economical builds more than I need to. But a lot of the reason I'm doing this is because in the past, the economy numbers that you would get were just honestly terrible. But in any case, now that we've done that, I think we can move the compression ratio. I'd like to get it up to 9.5, but we might not quite. Oh, there we go. That actually worked. So we're at 124, and I think I'm going to move with the ignition timing more than likely the rest of the way. One thing that we might have to consider here is increasing the exhaust diameter, which I think that is indeed the case as we do see more performance here. But I'm going to assume 2 inches is where we need it to be. So that would give us max power of 178. We could also switch out the headers, but I don't think I want to do that with this type of engine build. Let's continue on with the ignition timing. We're getting close to that number that I'm looking for, but we're just a little shy of it. We're at 127 horsepower, and I would like to get it to at least 130. That is my minimum level for this engine. And I'm using this, the comparison of the MR2 from around this period that would have had a 2.2 liter engine. So it's a little bit bigger displacement, but I believe it had somewhere around 100 to 135 horsepower from my memory. So we definitely need more performance if we're trying to match that engine. So the easy way to do that is change the cam profile. Might even bring it up to 60 here. Now this is hurting smoothness, but we did benefit smoothness with the change up of some of our parts. And this will also give us more fuel octane to work with so that we can push the engine a little bit higher. I'd like to get 135. That would be a nice number for me, I think. So let's check out the RPM limit. Do we need to change that at all? It does appear that we need to change that if we want the peak performance index, which is now at 6,900 RPM. And valve float didn't really get much worse, so I'm not too worried about that. Let's continue with ignition timing, as we do have room to move here. So far, getting pretty close to where, yeah, there's where it's going to knock. So we're at 133 horsepower. Now, I did improve the engine by 20 horsepower, roughly, is what I was looking for. I would really like it to get it to 135. I think that would be more or less what I'm looking for. But I don't really see necessarily an easy way to do that and keep this naturally aspirated. I could give it a performance intake, although I'm not sure how realistic that would be for this this model. Because the way I look at it with performance intake, I've envisioned this more as like an aftermarket option, not something that would likely come on a car like this as standard. You would more than likely have an airbox like this, but if I switch it to the performance intake, this is not something you would usually see on a car of this type in this year period coming standard from the factory. I think you would more likely see this type of air intake, and I don't like deviating from that. So as much as we could easily push that up to getting very close to that 135 horsepower that I'm looking for, I just don't like that option. So we could continue trying to push the cam profile here and get really darn close to where we want to be. Maybe 62 would do it for us. We might have to change the RPM limit and where that comes in. But, oops, that's not what I want to do. We could up the fuel mixture, and that was something I was accidentally doing. But let's see. Yeah, we're still at the peak performance index, so we don't really need to mess with the RPM limit. Let's give it just one hit of fuel mixture here, so we can get a little bit more ignition timing out of this. Darn. It's just being shy of where I would like it to be as far as performance. Let's hit it one more time. Come on, give me that one more horsepower. There we go. All right, so we got 135. I had to move that fuel mixture around quite a bit to get it. Let's see with our exhaust. Yeah, it's still peak. I think I'm happy with this. Let's go ahead and, interestingly enough, this is already called the SNA variant, and I used S to stand for star, and this is a satellite, which also starts with an S, which is interesting. So we're going to have to call it something else. We'll call it the PNA for performance naturally aspirated, and save that. I got the numbers I was looking for, more or less, so I'm pretty happy with this build, and I think we need to move on to the next engine, which is going to be the 1.6 liter engine that's going to be turbocharged. So this is the base engine for the satellite. And the next engine we're going to work on is going to be a variant of this engine, but turbocharged to try and get it to have more power. Now, there's going to have to be a lot of performance increases for this engine to get it to be where I want it to be. Now, first thing we're going to need to do is make a clone, of course. Grab that clone. Now, because this is the same family, we can't change the valves. One easy thing that I would do is make this 3 valves per cylinder to try and get more performance out of it. Unfortunately, we can't do that, keeping it the same family. I could build a brand new engine, keep all the other stats more or less the same, and just make that one change. But I like the idea of just having different variants of the same engine family. So we could do more or less the same kind of change we did with the other engine, which was switching to forged steel and then steel pistons and conrods, which makes sense. This is going to be probably the more expensive engine anyway. So let's go ahead and choose that. So we're forged across the board. Now this hasn't changed our performance at all yet, but it is going to improve our reliability and our smoothness. At least I assume it would have done that. Yeah, it should have. There you go. And also, it's going to allow us to push this engine harder, which is another thing that we definitely want to do. So moving along, one thing that we're going to do just preemptively is we're going to lower down the compression. I'm going to bring it down to 8 just to avoid knocking, as once you turbocharge an engine, it has the habit of really consuming a lot of fuel octane. As we can see there, we're now super knocking. I mean, with 96, we're really knocking. Now, we could up a number of things. First off, we're going to change the fuel mixture. Secondly, we can change the fuel type. We could either do premium or super in this engine, and I could see a justification for either one. I lean towards super in this engine, but I think I'm going to go with premium for now, and we'll see what that gets us. I'm also going to bring up the fuel mixture to at least where it was in our other engine, which was 14.3. I'm also going to change the exhaust diameter as we see the color change there. Now, I'm going to have to make a lot of tweaks with the turbocharging system. And if you've seen the previous video where I did the satellite, one thing I will freely admit is my lack of knowledge of turbocharging systems. I get a rough idea of what all this stuff does. But I definitely, of all the things that I know about cars, turbocharging systems and how they work and the best setup for a turbocharger for different situations is something that I don't really have a lot of knowledge of. So I might do a lot of the tweaking of the turbocharger off camera and then come back and show you where I'm at. In any case, I think for sure the last time I did the turbocharging setup for the satellite, I really honestly think I overdid it. And I really pushed the engine harder than I probably should have. In any case, as I said, I'm going to do a bunch of the tweaks off camera, and then I'm going to go ahead and show you what I did. Okay, we're back with the turbocharger setup, and I have it more or less where I'd like it at the moment. So I have all of these settings where I'd like it at the moment. There might be tweaks here and there. And I set up the intercooler that I'd like. Now, the bearing setup, I went with the journal bearing as it is more affordable than ball bearings, but ball bearings kind of affect how the power comes in, as you can see there. But with the intercooler, I went with air to air, and the reason I went with air to air is because I wanted to limit, if you see the direct comparison to the same size water to air, it's going to lower the weight a decent amount. It's also going to lower the cost significantly, as well as the production unit time. And there's an engineering time also, and I'm not really familiar with what that is. I think that's one of the newer additions to the game. In any case, it's lower there as well. So there's a number of reasons why I chose this, but obviously choosing the water air would improve performance in a number of ways, giving us better fuel octane numbers, giving us more to play with, increasing economy, increasing stats pretty much across the board outside of those downsides that I already mentioned. But for now, I think I'm going to stick with air to air. Now, the performance we're looking at the moment is not really any better than what we got out of the base engine. And this is more than likely going to be a more expensive engine as well, if not even heavier as well. I also changed a couple other things off camera, mostly just minimal things. So I changed where the RPM limit came in to where its peak was, so that went up a little bit. And I also brought the compression ratio up back to 8.5. Now, we still have room to play with, and I could bring this back to the 9 that it was at before. There's a number of other changes I can make to this engine pretty easily to get more performance out of it. Now, the question is, can we get the level of performance we would desire, though? Now, one thing that we can very easily do is, we cannot add VVL. Never mind. I was going to say that would have been an easy thing to do, and our engine might have been able to afford it in as far as parts reliability, which is one of the reasons we hadn't been using it in the past. But that's okay. We will just have to work without it. So as I said, we could probably increase this back up to 9, although, yeah, we're starting to get to the limits of what our fuel octane will allow with that premium fuel. So, I didn't want to move it that much. Let's bring it down to 8.5, where it was. Now, cam profile is definitely something that we probably should improve. As right now, it's pretty tame. Let's bring that up to, let's say, 60. Now for our base point. So now we're performing better than the base engine. One thing I'm noticing we're going to have to change here is the exhaust diameter. And also we probably want to give this a high flow three-way, which we haven't yet done. But let's bring that up to the 2-inch pipe. Do we need a 2.25? Hard to say at the moment. Let's go with high flow. Now we're getting 150 horsepower. Now let's try 2.25. It's still not really for sure on whether we need that exhaust diameter. Maybe as we push the engine a little bit harder, we'll need it. Now, as far as the muffler goes, we may actually want to just put a straight through pipe on here because the turbocharging system is actually having the side effect of quieting down the engine quite a bit. So we can, as a result, switch to a straight through muffler and have about the same loudness level that we're getting with the base engine. And this is going to have a couple different effects. It's going to definitely lower the weight and the cost of the overall engine. And I think weight is going to be an important consideration for us because the engine we're competing with, the base engine for the satellite, is all aluminum. This is cast iron, so it's going to be heavier more than likely, especially considering that we've added on this turbocharger equipment. So more than likely, we're going to have a disadvantage as far as weight is concerned, which means we're going to have to balance that disadvantage of weight with more power, for one thing, but we also want to limit the weight where we can. All right, after doing the tweaks to the engine, I've got the engine more or less at a performance level that I'm happy with. So we've got 176 horsepower and 149 foot-pounds of torque, which this is a little over 40 horsepower improvement of the standard engine in the satellite. So I'm happy with that, especially seeing how we have a lower displacement engine that we're looking at. In any case, let's go through the tabs and just take a look at where I have put everything. So the exhaust diameter is at 2¼ inches, and more or less I haven't changed any of the other setup. The fuel mixture is set at 14. We've got ignition timing of 63, RPM limit of 7,200. And the big change that we have here is I change it to a throttle per cylinder setup. So if we look at the single throttle as a comparison, we see that we drop off in performance index. It is increased weight, so we drop quite a significant amount of weight by switching to throttle per cylinder. Economy, I think more or less stays the same. I know it's green here, but it doesn't change by much. We lose a lot in throttle response. So by adding on the throttle per cylinder, I increase throttle response, which is something I was really looking for. Otherwise, we lose out a little bit in the octane by making that switch to the throttle per cylinder, and also cost and production units. But I like the boost that we get, and we also get horsepower and torque benefits as well. Technically not a torque benefit, but a horsepower benefit, definitely. All right, moving on to the turbocharger. Now with the turbocharger, I ended up restricting the compressor quite a bit. And I increased the turbine size and the AR ratio, as well as giving the turbocharger the max boost a little bit higher, more than a single PSI of improvement, so 1.2-ish, somewhere around there. As I believe I was at like 11, a little over 11 PSI before. Now I'm a little over 12 is where we're at. And cam profile set at 65, compression at 8.5, and there weren't really any changes over here to look at. So that's where we're at as far as the engine setup. As I said, I'm pretty happy with this performance boost. We definitely could get more out of the engine if we pushed it harder, but I'm happy with where the engine is. I don't want to push it too hard and get too ridiculous with the build, which is something I think I failed at the last time I used turbocharger in the satellite. Now, I ended up naming it the ST for satellite turbocharged. Let's just save that up to make sure it's saved. And let's make our comparison. I already went ahead and opened up all the other engines from 96 so we can get a direct comparison here. But the main thing we're going to focus on are the two variants of the satellite engine, which is the PNA variant here and the ST variant. So as far as power, we can see more than 40 horsepower improvement. And from the standard 1.6 liter engine, this is a very, very significant boost in performance, as well as torque. And the difference in torque here is more than 25 between the turbocharged version and the naturally aspirated version. Throttle response falls in the favor of the naturally aspirated engine. This is one of the reasons why I pushed a little bit harder for more throttle response in our turbocharged engine to kind of get it close to where we are here. This engine's a little bit smoother. It's a smaller engine. There's less reciprocating mass, so I kind of see where that's coming from. It is actually an improvement over the standard engine as well. That's probably due to the lighter weight parts we used rather than cast, pistons, conrods, and crank. We're using forged parts. Loudness is a little bit louder than the standard engine, but it's quieter than the standard engine, the satellite. So the standard engine in the Luna, a little bit quieter, but this is a sports car, so a little bit of extra loudness is actually something that you're kind of looking for. Now, reliability-wise, we suffered a little bit from the turbocharger. As a matter of fact, this is the least reliable engine we've built so far, but it's still above 60 or around about 60. And I think they rounded that up a little bit because the actual number is 59.7, as we can see down here, versus 61.6 for the standard engine in the satellite. I think that's fine with the turbocharger. You can expect a little worse reliability with the turbocharger. Now, weight I discussed, and I mentioned that I was trying to limit weight as much as possible, and that's because of the low weight of the standard engine. This being all aluminum construction, it's a lot lighter than the cast engine, especially after we've added on all the weight of the turbocharger and the intercooler and all that. Now, fuel economy, this is the worst performing engine as far as fuel efficiency out of all of the engines we've built so far, and that's because we push it harder for a performance build. And it is also worse than the standard engine, which I think is fine, all things considered. We're also using higher quality fuel, which this is the first engine to do so. Emissions are the worst out of all the builds that we have, even comparing to V8s. This is worse than even those. But, again, we're going for more of a performance-oriented build, so I don't really care so much. Now, production unit-wise, definitely this takes a lot more time and money to build than the standard naturally aspirated 1.6-liter engine. But we see that actually, cost-wise, it is cheaper than the naturally aspirated version in the satellite, but it is more expensive as far as production units. So that may balance out a little bit, but keeping these engines pretty close in cost. So if we were just to compare other engines out here, for instance, the turbocharged inline 4 that we have in the satellite versus, for instance, our V6 and the Star, we see that we get more performance, at least as far as horsepower, but not as good torque. We get better throttle response. It's a little bit more smooth, but we don't really care about that so much. Loudness, it's quieter. I mean, at least the V6 is quieter than the turbocharged engine. But again, these are not the same idea of build. More reliable here, not so reliable here. We kind of got that. Weight's going to be a big difference. Economy, we already said this is the worst performing engine here. And emissions, again, worst performing. But production unit and overall cost is lower. So we get somewhat equivalent numbers. I mean, we get an edge here in torque versus the torque that the four-cylinder engine is producing, but we have an edge in horsepower here. Now, once you get up into the 3.6-liter V6s, it's not going to really be able to reach that. Even the, more economical build for the Asteroid, where we actually purposely cut back the power so that we could put less expensive parts in there. We made it lower revving. Still, we're not really able to compete there. This has more horsepower, it has more torque, has the same throttle response, and so on. So we're not quite competing with the larger displacement V6s, but coming close to a 3-liter V6, I think is more or less what we're looking for. So I'm pretty happy with the build, and I hope you guys have enjoyed this video. This is Mouse Gunner, signing out.